Okay, so welcome back, and now we're going to continue on with this basic example that Nelson is putting together with the basic JSON subset lexing and parsing. So in this video here, what we're going to be doing is focusing on the creation of the lexer rules.
Yep.
Nelson?
So the Lexar rules, this is going to be a relatively simple language. So we really only need to parse out things like strings, numbers, identifiers, and we definitely need to get some white space and sensitivity in there. Other than that, though, that's pretty much all we're going to be needing to continue and build our rules up,
Okay.
our parser rules up. So I'm going to start with the basic one, ident. And you'll notice that a rule, whether it's a parser rule or a lexer rule, it's always going to follow the same sort of format. It's going to be the name of the rule followed by a colon followed by a semicolon. What goes in the between the semicolon and the colon is the rule itself.
And as you said earlier, since we're starting this off with a capitalized I, that means it's going to be a lexer rule.
Yep.
Okay, and the other thing that I wanted to point out is ident. It's not like a keyword or anything. You could have called it anything that you wanted to, actually.
Yeah, it doesn't really matter, but
Best one ever. Okay.
I mean, we could have done identifier as well, but I'm lazy, so we're going to keep it on an ident.
Okay.
And yeah, there's no rules as to what you call your things. Other than be careful about this. Try not to make your rules be the same name as a keyword in the target language.
Yeah, good point.
That will destroy your sanity. So no classes, no interfaces, no virtuals, no anything that's a keyword in C#. Don't use it as a name.
Okay.
So what we're going to do is write the ident lexer rule. Now we could write it all out as an entire lexer rule, or we can break it out into what are called fragments. So I'm going to show what I mean by that. An identifier is always going to be, in this particular language, this subset of this particular language. Remember, this isn't true JSON. An identifier is simply going to follow the same rules as C# identifiers, with the exception, of course, of the @ symbol. So basically the rules are, we want something to be matched as an identifier if it starts with a letter or underscore and continues on as either letters or digits or underscores. So there's two distinct parts. We have an ident start and an ident mid. An ident start will always be just one thing that's parsed out, and the ident mid is going to repeat 0 to many times, which is why I add the star at the end of that. Now, we haven't actually defined these lexer rules yet. We're not going to define them as real rules, and the reason is I'm doing this to clean up the code file quite a bit, but we don't ever want the lexer to return an ident start or an ident mid. We just want to use it in the context of the ident lexer rule. So we're going to define what are called fragments. A fragment rule is a rule, is a lexer rule that starts with the word fragment, and it's basically going to be a way for us to reuse little bits and pieces of our lexer rules without having to worry about these fragments ever showing up to the parser. So let's go ahead and get our fragment
Ident mid in there.
Ident mid, and so now we have our ident start and ident mid.
Okay.
So what is an ident start? Well, I said an ident start is either an underscore or a letter. Now we haven't defined letter yet. What's the letter? A letter is A through Z or A through Z. Now the pipe symbol again is an OR. If we go ahead and actually select ident start, we'll see that it can match, with this particular syntax, it's going to match any of these things. Mm-hmm. And so the OR simply means, well, OR. An ident mid is going to be a little bit more complex. It's basically actually going to be an ident start plus a digit. Now what's a digit? Digit's going to be another fragment. That is simply 0 to 9. So at this point, we now have identifiers being parsed out properly. We're not going to be showing anything in the interpreter in this video, but by virtue of the fact that the interpreter requires parser rules. But at this point, our lexer can understand identifiers and properly send them off to the parser for, well, parsing.
Okay. Now, I noticed down on the bottom, and this could just be AntlerWorks, but it just says errors reported in console.
Yeah, as something about Antler works is as you type, it'll report errors immediately, even as you're fixing errors, and then it's not going to make that disappear until you click on it. So it is something that is slightly annoying. As you are typing, you're always going to be generating syntax errors, but just make sure to clear it every now and then so you don't lose your sanity.
Yeah, something good for our viewers to know. Okay, so we'll go ahead and wrap up this video. And what else? Oh, you got...
Yeah, we have numbers, we have strings, and we have white space.
Oh, that's right.
Alrighty. So
all we can have is an identifier. That's awesome.
So yeah, I'll start off with the number one just because that's really simple. Check this out. The number Lexar rule is going to be a digit, one-to-many digits, it's going to be one-to-many digits, or it's going to be a optional digit followed by a dot followed by 0-to-many digits.
Ah, very cool. Ooh, I love the graph. That's nice.
Yep. So we can see we start off with 0 to 9 repeated.
So so like the top branch is kind of like an integer, and the bottom one is kind of like if we had a float or a double or something.
Yep. And we can also support dot and then numbers as well. But we can't, with the way that this is set up, we can't have multiple dots, for example. So that's nice.
Yeah, very cool.
The next thing I'm going to do is strings, and strings are a little bit more complex. I'm actually going to break this out into 2 lines. So a string is going to be a single quote followed by, and this is where things get weird, followed by not a /n, a /r, or another single quote, 0 to many times, followed by another single quote.
Whoa. Okay, so right above string, perhaps make a throw in some comments and just kind of give an example for anyone that might be having trouble following. You know, how does this actually? What are you watching for, basically?
Oh, well, I'm watching for a single quoted string like that, which you might not be able to see very well. But basically, what we're saying is, okay, go ahead and start off with a literal string, and then continue indefinitely until you find one of these symbols in here. That's what this not means. This means not one of these. So it says, okay, hit one of these quotes and then continue on, eat everything except for if you run into a new line, a line feed, or another double quote, then stop. Then expect another double quote at the end.
Is that a double quote? Okay.
A single quote. So if we were to have like this, for example, where we don't terminate it, what's going to happen is it's going to start with this. It's going to be like, all right, well, I'm going to eat up all these characters. Then it's going to hit the new line. It's going to say, okay, so we're out of this loop now. Expect another single quote. Wait a sec, there's no single quote. Throw an error, just like you would expect.
Gotcha. Very cool.
Okay, the next thing we're going to do with strings is we're going to support double quotes. So I'm going to take this, copy and paste it. And then I'm going to add an or symbol. Then I'm going to change these single quotes into double quotes. So pretty straightforward. So we support single and double quotes with our strings. Now the final thing.
Did you also want to inside your not? If we're using double quotes?
Yeah, good catch. Okay, yeah, so we'll make sure that we'll terminate if we hit another double quote.
Okay.
So, yes, the last thing we're going to do is white space. White space is pretty straightforward with one added twist. White space is going to be a T. Or it's going to be a space. Or sorry, what am I doing? Or it's going to be a line feed, or it's going to be what?
So, no, I was just going to say, and what he means by it's going to be a T is it's going to be a tab.
Tab, yeah, that's what I meant. And then it's going to be one to many of these. So that'll match white space. We have white space match, but we don't want to send it to the parser because the parser will get all confused because this is not a white space sensitive language. So what do? We throw in some curly braces, and inside of our curly braces we do channel equals hidden.
So talk about that for just a second.
So channel equals hidden is going to be an action that says this rule, this Lexar rule, is now going to be basically effectively ignored by the parser. None of the token, this particular token, which is constituted by a tab, space, line feed, or new line one to many times, will be sent to the parser, but in the hidden channel, and the parser will never examine the hidden channel.
But that is something that is available to us later on if we so need it.
Yes, I've run into instances, especially with CGS, where I needed to know if the preceding token was a white space, and that's entirely possible to do.
Awesome. Okay.
So I think that really wraps up our Lexar.
Fantastic. Then we'll go ahead and wrap up this video, and in the next one, we'll go ahead and start talking about the parser rule or rules and seeing this thing in action in the interpreter. So thanks a lot.